let's look at some more inequalities. With inequalities, we can do all of the things that we did with equations when we were looking at linear equations, except we have to be careful if we multiply or divide by a negative number. Then we have to flip the inequality. But otherwise, we can add and subtract all day long. We can multiply by a positive number, divide by a positive number. So in this case, we want to get x all by itself on the left-hand side. So the first thing we need to do is move that 1 over to the other side. So I'm going to go ahead and subtract it from this side so that we have 0 on that side, but that means I have to also subtract on this side. That leaves me with 3x on the left-hand side and negative 6 on the right-hand side. At this point, again, we want x by itself. So I need to have 1x, not 3x. We're going to do the opposite. Remember, 3 next to an x means 3 times x. So I'm going to go ahead and divide by 3. Not divide by 3x, just divide by 3 because I want 1x left. And then on the other side, I also have to divide by 3. So what that leaves me with is x less than negative 2. Now they're going to want interval notation again. So let's go ahead and look at our number line a second. We want all of the numbers less than negative 2, but we're not going to include negative 2. So you see over on the right-hand side, we've got less than, greater than our parentheses. That denotes that we do not include the number, but we're right next to the number. Less than or equal to, greater than or equal to are square brackets. That means we do include the number. So in this case, we're going to start at negative 2. We're going to head to the left, just like the inequality tells us. So we're going to use a parenthesis because we're not including negative 2, but we're going to start at the closest decimal right after, and then we are going to head to the left. What that tells us then, when we go to put in interval notation, we're starting way out at negative infinity, and we're stopping at negative 2. All right, let's try the next problem. The next problem has 2 inequalities. This is what we're going to see when we start working with confidence intervals in chapter 6, I believe. And so we have 2 endpoints still, but we're not going to have the negative infinity and the positive infinity. This time, whatever we do to the middle of the inequality, we have to also do to both ends. So we have to be careful here. We again want 1x in the middle. So I'm going to go ahead and add 2 to get rid of that 2, but that means I have to add 2 on both ends. All right, so now I have 2 less than or equal to 5x less than or equal to 20. At this point, I'm going to divide by 5. Ooh, I picked a problem with a fraction, but that's okay. We can do this. And so that leaves us with 2/5 on the left-hand side, x is in the middle, and 4 on the right-hand side. That means we want every single number, every fraction, every decimal between 2/5, 2/5, including 2/5, all the way up to 4 and including 4. So let's look at what the number line would look like. We're going to go ahead and start at 2/5. I'm going to kind of guesstimate that. We're going to end at 4. And then we're going to use every single number in between. Therefore, when we go to put this in interval notation, we're going to use brackets because it's less than or equal to. So we're going to start at 2/5. That's our start point. Not a very good 5. Let me fix that 5. And we're going to end at 4, again, including the 4. So sometimes we see the word inclusive. Sometimes we see the less than or equal to or greater than or equal to, but it means that we're going to include those endpoints. And so this is our answer for interval notation.